This conference will now be recorded.
Hey, everybody. Good morning. Good afternoon. Thank you for joining us on another Cloud Communications Alliance webinar. Want to thank you. And for you who are already on the call, you saw a little bit about how the sausage is made. So you saw behind the scenes. Not everybody gets to see that. So we're going to do this session today using our GoToMeeting platform. You all been on a lot of our webinars already, so I'm sure you're familiar with the buttons. You can mute yourself. You can turn on your video. You can do all kinds of things, change the view. So feel free to play around with it and get yourself a comfortable view that you like. But we really have a great webinar scheduled for today. I'm going to turn this over to Mark Iannuzzi, who's the chair of our Government Relations Committee, and let him introduce the subject. Mark, it's all yours.
Thanks, Joe, and welcome everybody. Once again, my name is Mark Iannuzzi. I'm the president of Telnet Worldwide. Telnet is a facilities-based carrier headquartered near Detroit, Michigan. I have the privilege to serve as the director of the Government Affairs and Regulatory Committee for the Cloud Communications Alliance. And our goal of the committee is quite simple. It's to keep our members the best informed in industry. And to that note, today we have a great presentation lined up for you. It centers on security and safety. These are perhaps the most important aspects of our communications network. Time and accuracy mean everything when health and safety are at risk. As service providers, providing access to the 911 network is a fundamental duty and frankly an opportunity to differentiate. Technology shifts, for example, from TDM to VoIP enhance many things, but they also bring about new challenges. Today we have the good fortune to have a few noted experts in the field. And if you want to advance the slide there. We have Mr. Michael Pryor. Michael is a member of our committee of the CCA. He's an attorney and shareholder at Brownstein, Hyatt, Farber, and Schreck. And Thomas Ginter, he's a 911 solutions engineer for bandwidth, and he will be providing insights on how to enable and maximize the continuing evolution of 911 landscape. So we'll start off with a little bit of regulatory and legal stuff, and Michael, we'll pass it off to you, sir.
All right, well, thank you very much, and thanks everyone for joining. I'm going to provide just a few minutes of high-level information on the fundamental regulatory obligations, and then Thomas will show you how to comply with this stuff, which is the more interesting part of this presentation, I think. So if you please go to the next slide. So let's start with some of the key dates that were brought into effect by the FCC in an order in 2019 that implemented what I'm sure many of you know is either the Carey's Law and the BAUM Act. So the key date is February 16th, 2020. That's the date by which any equipment that's sold or installed after that date has to comply with the regulations that we're going to discuss. Carey's Law, as you know, is the law that required direct 911 dialing and the provision of a notification to a central location that a 911 call has been made. Again, that's an old date. Everyone should be in compliance with that by now. The next date was this January 6, 2021, which was the date by which providers should be, and their systems should be providing automatic dispatchable location information along with the 911 call for fixed on-premises devices. So again, another deadline that's already passed, and you should be implementing it. And I should note that when we're talking about enterprise 911 regulations and enterprise services, we're really talking about multi-line telephone systems that can be on-premises or can be cloud-based. Finally, we get to what we're really going to talk about today, which is the next upcoming deadline on January 6, 2022. You're going to have to be providing dispatchable location for non-fixed devices or for off-premises devices. And one thing I want to kind of clarify is even though these implementation dates of January 2021 and January 2022 Those dates are effective dates for regulations, but they apply sort of backwards to any equipment that you sold or installed after February 16th, 2020. So that's the key dates. Next slide, please. And we'll talk about what dispatchable location is. It's defined as providing a validated street address plus some additional information such as a room number, a floor number, or some other information that's necessary for the first responders that are responding to the call to identify where the calling party is. The dispatchable location requirements are actually designed to be flexible and functional. The degree of granularity for where a specific caller is calling from obviously varies depending on the kind of the environment. A small business, you might be able to get by just with the normal street address, but if you have a multi-story office building or office or a campus environment, then you have to get more granular. And as I mentioned, that dispatchable location information must be automatically transmitted. And there is some possibility to still provide some sort of manual input because the end user may be the one who knows where things go. So if we can turn to the next slide. Let's start with non-fixed devices, which is, again, what the upcoming deadline applies to. And the rules kind of vary depending on whether we're talking about a non-fixed device that's on premises within the enterprise or whether it's off premises. So if it's an on-premise soft phone that you can pick up, move around with you, you have to provide a dispatchable location if it's technically feasible. And again, that could require the end user enterprise to provide or confirm a location manually. But if it's not technically feasible to provide dispatchable location, you can provide something that's called alternative location information. It's somewhat less precise. It can be coordinate based, like an XY or XYZ location. And again, it's to provide sort of an approximate building location. So for example, you might not be able to provide a room number, but you could provide a floor number and a quadrant of the building, for example. For an off-premises location, which is even trickier, there's still even more flexibility provided. If it's technically feasible, you have to provide dispatchable location information. Alternatively, you could try to get some kind of manual update of where the caller is located, or you can use something called enhanced location information, which is sort of the best available location information available at a reasonable cost. One more slide, please. So the FCC's rules assign different responsibilities for ensuring that these capabilities are in the systems. There are responsibilities for those who lease or sell to ensure that the systems have the capability after proper installation to provide the dispatchable location. If you are installing, you have to make sure that the system is configured to be capable to be programmed with and conveying dispatchable location. And if you're operating or managing the system, you again have to make sure that they're configured to provide dispatchable location information. And we recognize that one company might be providing and performing a number of these different functions. The key thing on the legal side is if there's ever a problem, is who's responsible in the first instance. And the FCC is going to first take a look at who the entity is that's managing the system. And they're going to presume that that manager is responsible. But this is all really a matter of contract between these different entities. So you want to make sure your contract language has some clarity about who's responsible for what. I wanted to do this kind of high-level overview fairly quickly because I think most of you are probably pretty familiar with it. And I wanted to turn it over now to Thomas, who can talk to you about some ways to actually comply with these requirements. So Thomas, take it away.
Thank you, Michael, and it's great to be here. Also, I extend my thanks, Joe, to your invitation to participate in this CCA webinar today. Okay, let's do 60 seconds on the first question, which nobody's asked, which is, who is bandwidth? And then we're going to get into the details of the toolkits and technologies available to you to build these regulatorily compliant 911 solutions. So the audience I'm going to be speaking to today are you, the CCA members, who are concerned with compliance, concerned with the use cases of, I've got a laptop device, it's sharing a phone number with a mobile device, it's sharing a phone number potentially with a desktop device. I've got multicast, I've got people moving around, I've got Wi-Fi connectivity. How do I do 911 location delivery in these increasingly complex and increasingly virtual environments? That's the problem we're going to be solving. I'm going to explain by way of reference to some of the companies on the right hand of the screen. So first things first, who is bandwidth? I always like to describe bandwidth as the largest voice over IP network provider that you have never heard of. So we literally have a network in the United States and 60 additional countries across the globe. In the US specifically, we have approximately 15,000 interconnection points to the public switch telephone network and many, many companies that are handling inbound and outbound telephony. So you can view bandwidth, again, you might not have heard of us, but we're the power behind the brands you see on the right hand of the screen. And we provide our network services, which includes voice, SIP trunking, telephone numbers, IM or messaging or SMS associated with any telephone number, and of course 911. And we provide that through our network, through a network edge of session border controllers, through a network edge of provisioning APIs, through a network edge of provisioning portals. So you won't see us, providing service to a residential customer. That may be one of your customers, but we're a network that you can attach to so that your cloud is powered. You have to be attached to something. And we're that wholesaler that's behind the scenes for the folks on the right-hand side of the screen. They don't have facilities. They use us, and that's enough about bandwidth. Next slide, please. All right, we're going to focus on 911 location. Okay, and again, I'm going to provide a toolkit of solution capabilities here that you can think about as you're trying to solve some of the most complex use cases or the most innovative solutions that you're putting on the market. Call center solutions where you have people who might need to make a 911 call, but they don't actually have a phone number. Solutions where that call center or your employee arbitrarily moves to a work from home or to a hotel environment. How do you keep up with location? Laptops that move around an enterprise building or a plurality of buildings on a campus like a university. How do you keep up with this new set of rules? We're going to talk about those solutions by way of example through some of the companies I listed on the previous screen. But first things first, let's get a little bit of nomenclature, a little bit of terminology locked down. Next slide. All right. In the world of voice over IP, you will hear folks like Bandwidth and other folks in the 911, wholesale provider space talk about I1 technology, I2 technology, and I3 technology, okay? And you will also hear even more people talk about basic 911 and enhanced 911. Okay, let's disambiguate some of these terms. And this might be pretty basic for some of the audience, but we want to cull out a couple of very key points on this language. Number one, basic 911 and enhanced 911 are terms used by the wireline legacy industry, the AT&Ts and former CenturyLinks and Verizons of the world when they were providing, in the 1980s, basic 911 service, which is voice connection only, or enhanced 911 service back in the 1980s and 1990s that delivered address information for the very first time. Those two terms, basic 911 and enhanced 911, don't pertain to voice over IP, except by use of overuse of the term. It's like the use of the word Kleenex instead of bathroom tissue. Okay. So what is I1? I1, and you look at this from the perspective of the public safety answering point or that 911 call center, when they receive a basic or an I1 911 call, the only thing that's on their screen is the phone number, and they get a two-way voice connection. There's no other information that's displayed on the screen. There are, out of the 5,545 911 call centers in the United States, there's probably still around 120 who are basic. This is not your problem. So if you're a CCA participant looking for 911 solutions, don't worry about the basic guys because they can only receive your call. All of the stuff we're going to do about Kerry's Law, BAUM's Act, location display, doesn't pertain to a public safety answering point that can't receive and display it. So we can kind of move off of I1. I just want to clear that point. Next is I2, and this is the preponderance of your voice over IP 911 solutions that are out there today. If you are doing 911 on a VoIP connection, you are most likely doing an I2 connection. And what is displayed on the public safety screen, I always think of it as a triplet. That's your name, number, and address, or your name, number, and latitude, longitude information. That's what's on. That's what's here. You're going to hear me talk about I2 protocols, session border controllers, and APIs as an example of how to solve some of the use cases in just a moment. But now we get to the I3, and this is the part that is a little bit confusing to people in the industry. I3 is the technical term by NENA, N-E-N-A, the North American Emergency Number Association, for the body of protocols for next generation 911. Next generation 911 is this big promise of a lot of modern capability for public safety. The key here is that Next Gen 911 in the media talks about pictures being delivered to public safety and video being delivered to public safety and text and IM and real-time text and all of these capabilities. They don't pertain to you, the VoIP provider. And on the screen, what you see here on the screen of the public safety answering point is still the same triplet: name, number, and address information. And that is the only information that is pertinent to the Kerry's Law, BAUM's Act compliances. So you'll see for the rest of this webinar, me focus on name, number, address display, because you don't have to do more than that. Well, if you have a business case and there's a business opportunity for you to do more, by all means, we can talk about that. But today we're talking about compliances. And so we're focused on I2 solutions, which have been in the market for a decade, and I3 solutions that have been in the market for about 24 months now. And that's the new thing that you might be able to make use of in your endeavor as a CCA participant, industry participant, to be compliant. I hope I have made that clear. Next slide, please. Okay. I promise that this is the most complicated slide that I'm going to talk about, and that it won't get any more technically complex than this. But this is, and we're only going to spend a minute on this. If you need an explanation of the complete call flow of how a voice over IP I2 call moves from the far left-hand side of the screen through your switch, through your voice over IP switch, doesn't matter what make, model, and vintage of it is. Could be a Metaswitch, could be a NetSapiens, could even be a Cisco Call Manager or a Broadworks. There's plethora of brands, or it could be your own software or stuff built on an asterisk or a free switch. You're the blue blob that says VoIP switch, okay? And as we move the call from the far left-hand side of the screen through your session border controller over to bandwidth, which has that interconnection to all of public safety in North America, you're connected to all of your customers, and you have hundreds, thousands, tens of thousands of customers on your side. They could be anywhere. They need to come over to bandwidth through that SBC to SBC connection, and we can in turn deliver the 911 call, name, number, and address downward through the screen on the left-hand side, through to public safety, converting from voice over IP to legacy systems, if the 911 center is legacy, through what's known as Selective Router Alley Database. That's the SR and the ALI that's on the screen, all the way down to the PSAP, Public Safety Answering Point. That's your 911 call center. We're not going to talk about all of the kerplunks of that call going from the far left all the way to the far right and down. What we're going to focus on is that you have data, name, number, and address, that needs to get to public safety, and we're going to talk about the I2 and the I3 tools in order to get that data over to us so that we can handle all of the kerplunks down to that public safety answering point on the bottom of the screen. Okay, one key point. In order to design new solutions, you need to understand the most common solution that you're probably working with today. And that is, and here's the secret, that is that a 911 call that comes over to bandwidth from enterprise systems and from cloud systems very often doesn't have its own phone number. Okay, it actually uses a proxy number, and in the industry, there's a lot of terms for these proxy numbers. There's ELIN, Emergency Location Information Number, or CCID. There's a bunch of terminology here, but I'm going to use the word proxy, and here's the key point. Very often on these enterprise systems and cloud systems, the 911 call that comes over to us doesn't have a location for the telephone number of the user because the user is in a building. And the building might have 1,000 people in it, and 1,000 telephone numbers, and 1,000 extensions. And so provisioning over with public safety thousands of these endpoints isn't that efficient. And so what happens, and this is the key point, what happens in a lot of 911 systems using I2 today is that, say it's a 5-story building, and there's 100 people on each floor of the building. The building and the phone system of the building and the phone system of the cloud PBX, will have a proxy number, an ELIN, a proxy number associated with the first floor and the second floor and the third floor. There'll be 5 of these numbers, and over on the public safety side, on the bandwidth side, you'll have provisioned that proxy number for the first floor saying the address of the first floor. So 123 Main Street, floor 1. Then there would be a second number for 123 Main Street, floor 2. And so you'd have 5 numbers that represent the 500 phones in the building off to public safety. There is a number swap at the time where the endpoint, where that phone in the building dials 911, and it's not their number that goes out. The building PBX goes, where is that phone? Oh, it's on the first floor. Swap out the calling party ID for this proxy number, this thing called an ELIN, and send that off to a company like Bandwidth, and we will go, oh, what's the pre-provisioned address information for that phone? It's 123 Main Street, floor 1, or 123 Main Street, floor 5 if the device was on the 5th floor. That proxy number technique, you're going to see it used here in a couple of examples. Now, the key point is that if the person leaves the building and goes home, the use of the proxy number breaks. Okay, because that building PBX, your cloud service, doesn't know that the person went home, and they might see through a VPN that they think it's still, say, on the 3rd floor and present the wrong address information to public safety. Okay, that's the kind of problem we're going to be fixing in the next several slides. All right, one last technical point on legacy solutions. For these, and I'm going to list off a number of brands. By the way, when I name a brand, I'm not advocating any particular brand. I'm just using these by way of example, because if you dealt with those types of equipment in the past, then you go, okay, I know what this Thomas guy is talking about. So that the brands are just references. So Cisco Call Manager uses ELINs, and Avaya uses ELINs, and ShoreTel Mitel uses something called a CCID, but it's all the same technique. And for those systems, how do they know that that phone is on the 1st floor versus the 3rd floor? Well, there's a router in the building and a switch port cable, a cable from the 5th floor that goes to the equipment room, and there's a switch port mapping or an IP port mapping that's done to go, Bob is making a phone call from the 3rd floor. I'm about to make this 911 call. Okay, where is he? He's at the following switch port, or he's at the following IP address for that particular floor. Oh, that's in the set of IP addresses or switch ports for that floor. Use the following proxy number for the 3rd floor. Send the call off to the 911 service provider. Okay, that's the legacy technique. And again, I apologize. This is the most complex slide. We do webinars for an hour on this slide alone. So if you need more help, by all means, contact us after, and we'll get into the details. Let's move forward into solutions for mobility and nomadic. Next slide, please. Okay, RingCentral. RingCentral, you're going to see a circle here on the screen, and you're seeing now for the very first time a wireless access point. Well, what's going on here? Okay, again, this is not an advocacy of any particular product, nor is this the only 911 solution that RingCentral has. So I'm taking this as an example of an I2 implementation. And by the way, this is all available on their website. You can do a couple of Google searches and come up with all of the pictures on the next series of slides. So there's no secrets here. Okay, but what's new on this slide is you see a Wi-Fi access point. Okay, well, on the previous slide, we said, okay, we've got a building, it's got a switch, it's got switch ports, or it's got IP addresses for a particular floor, and there's a proxy number for those physical address points. And when the device makes a call, it uses the proxy number for that floor based on switch port, sends it off because we have an address for it. Well, what RingCentral has cleverly done is they recognize that your laptop isn't on a switch port. You know, and your laptop isn't using a particular IP address because there's probably a little bit of jargon. There's a NAT address that's probably proxying the IP address. Lots of use of the word proxy. But what they do, and this is an I2 solution, is that they tag every Wi-Fi access point in their building or in the plurality of buildings on a campus. Every Wi-Fi access point gets tagged with its own proxy number, same term, its own proxy number. That proxy number gets stored with the emergency services provider like bandwidth, and that proxy number for this, for example, Wi-Fi access point on the third floor of that same building, 123 Main Street, third floor, it might be the cafeteria, okay? And when any laptop in the cafeteria makes a 911 call, it goes, oh, where am I? I'm going to use the proxy number associated with that Wi-Fi access point. And so we facilitated the first class of problem for you, the CCA members. How do you handle location when the laptops move around all the time? The first technique is to use the I2 proxy number technique to tag not only physical connections like cables and plugs in the wall and switch ports, but also the other electronic media, the wireless media that you can use to connect. And presto, next slide, please. What you'll see is we've simplified the diagram now. In RingCentral, they have this thing called a LIS, L-I-S, Location Information Server. You actually would have seen one on the slide 2 slides ago because Bandwidth has a LIS as well. What is a LIS, L-I-S, Location Information Server? It is the repository of those electronic datums, the switch port, the IP address range, the subnet range, for example, or this Wi-Fi access point, and its associated proxy number and its associated specific, and here's where we get regulatory, its specific BAUM's Act compliant location. So RingCentral provides through that little portal that I just showed a way of provisioning all of that stuff and associating a proxy number so that any device that makes a call from any port in their environment or any Wi-Fi access point in their environment, regardless of it being a hard phone or a laptop, being able to facilitate BAUM where it is because we tag them using this I2 technique. So this is all stuff that's available through SBCs and APIs. Again, I'm not going to get into the protocol. I have identified a class of solution used by a product at RingCentral, and you can do the same thing. This is one of the techniques. I hope that's clear, and we'll move on to the next slide.
Yeah, and Thomas, I'm glad you emphasized that now we're getting to the point with that kind of solution where you're getting to the definition of dispatchable location, because you're able to provide not just a floor number, but a specific Wi-Fi access point would give you a much more granular location than just a floor number or something like that.
That's precisely it. That's precisely it. Okay, so here we have another example. Again, explanation by way of example. We have, in this case, a Zoom example. And you'll see on the top, it goes nomadic and I3. All right, what's I3? Well, this is next gen. Now we know from my previous slide that we're still focused only on delivering the triplet, name, number, address information to public safety. And let's not be distracted by pictures and live video and maps of the floor and everything. There aren't any video and maps involved in the regulations. We're just focused on compliance, name, number, address. And over on the far right-hand side of the screen, you can see there's a work from home location that's being provisioned. Okay, so here we're now going to use an I3 technique, I'll explain it in a moment, to solve work from home. We used an I2 technique, the RingCentral example, to figure out laptops moving around a building using Wi-Fi and the proxy technique. But when the person goes home, okay, the IT department, the RingCentral example, breaks. Why? Because you don't know what the IP address or what the Wi-Fi, access point is in your home. It could be provided by a completely different vendor. It's probably provided by Spectrum. It's got nothing to do with Zoom. It's got nothing to do with RingCentral. So there's an opacity, an inability to see and provision those foreign Wi-Fi access points to create this level of automation. And we have someone who really needs to mute because there's music on the line. There we go. Okay, so what we're going to do now is we're going to use I3. What's the magic of I3? In I2, your voice over IP call setup, and this is going to be a little bit of jargon for you developers, the voice over IP setup in I2 is a SIP invite, a session initiation protocol invite, with a to field that says 911, a from field of the phone number, we talked about that proxy number, and that's it. In I3, we have the SIP invite that contains the to field of 911, the from field, which now is going to be the individual's phone number exclusively, okay? And in I3, we include new modern geolocation content. The geolocation content can be an address of the home, it can be a reference to an address of the home, or it can be a latitude, longitude. And in this case, what's happening, and now we can flip the slide forward, is that you will observe another list in the Zoom side. And that list is no longer just containing the enterprise building, switch ports and subnets and IP, intranet IP address ranges, but that list is now also going to contain all the work from home addresses of all of the users. And you have, a GUI for that or a pop-up on your screen for that, okay? And at call time, when the Zoom call comes over to bandwidth, it's using an I3 technique so that not only is the telephone number presented, okay, but the geolocation is also going to be presented as well. And so we actually get the location of the moment in the SIP invite. Okay, this is call time location delivery or location determination as opposed to provisioning time location. In the I2 solution, you set up your Wi-Fi environment. You could set it up in 2019. You make calls. It's now 2021, and a 911 call occurs, and it's using the provisioned information that you set up in 2019. But in the I3 technique, Bob can go home. He can go over to his sister's place, fire up his laptop. The laptop observes that he's moved location. Many ways to do that. Just use Bing Maps or an API, and it'll go, "Oh, where are you now, Bob?" And it says, "Oh, well, I'm at my sister's house." Validates the address. That goes into the list shown on the screen now. And at call time, 60 seconds later, makes the call, comes out of his Zoom, call over to bandwidth, and it says, "Oh, the address of record for at this moment is not a provisioning time address. It's at call time in the SIP invite." That's what I3 is providing. Okay, so now we have solved for work from home using this I3 technique. And by the way, on the bandwidth side, a little bit of advertising. This product is called our dynamic location routing product. Maybe not the cleverest name, but dynamic location routing, location at call time routing. And this is a technique used, again, by this product offered by Zoom. And again, it's in the public, so no secrets here. That's how they're doing these types of solutions. Okay, one more, and we're going to solve for one more problem. I'm going to show you the toolkit. Next slide. Okay, Microsoft Teams. So claim to fame, Microsoft Skype for Business used i3 technologies as far back as 2012, 2013, so they're not new to this. And they're actually fairly advanced in their LIS implementation and in their ability to provide geolocation information using i3 at call time. That was a mouthful. I'm going to say it a second time. Microsoft uses geolocation information at call time in their SIP invite, and they've been doing it since about 2012, 2013. It's quite advanced. Okay. And you know, if you've ever used Teams, that you may or may not have a phone number. And so now the problem we're going to solve is, what about 911 calling from a virtual user who doesn't have a phone number, right? And how is that handled? Okay, so in this Microsoft environment, again, you've got a couple of screens here. They provisioned the same stuff in that LIS, that location information server on the Microsoft side. You know, Wi-Fi access points that are on the enterprise, work from home addresses that are collected, subnets, all of that good stuff, so that when the 911 call is made, at that moment, the Microsoft Teams environment can say, where is he now? Send the call across an i3 trunk over to bandwidth. Okay. But what if the person doesn't have a phone number? Earlier I said a SIP invite with a to field of 911, a from field of a phone number, and then the geolocation information. But what if he doesn't have a phone number? What if all that my account is in Microsoft Teams is thomasginter@bandwidth.com? You know, I don't have a phone number. Well, in i3, you can use additional parameters, and this is again a little bit of jargon. You can use a p-asserted identity to use an alphanumeric string that says Thomas Ginter at bandwidth. You don't need a phone number anymore in an i3 implementation to identify the end user. You can use an arbitrary URI type string to identify the people. So we solve for non-telephone number identification of endpoints. Over on our side, there's a little bit of design around what number to present to public safety, what callback number. And this gets into the implementation of, okay, so we've got 1,000 users, none of them have telephone numbers. We're going to use their IDs. We're going to create a pool of, say, 10 numbers to present to public safety, and just keep a record of who the most recent 911 caller was for each one of those numbers. And if public safety dials that number, we're going to route it back to the Thomas Ginter at bandwidth handle in the Microsoft Teams environment. That's a lot that I just said, but the trick here is that you can take home the knowledge that between I2 solutions using proxy numbers and provisioning interfaces, and using I3 with direct telephone numbers, and I3 with user IDs, not phone numbers, and I3 with geolocations of the moment, you can solve for the use cases that we've been talking about as the problem statements created by, or maybe not created by, the regulations, but that certainly need to be complied in conjunction with those regulations. All right, I sure hope that was clear. and we can move to the next slide. Okay, so this is the Microsoft Teams implementation, and what you'll see is, again, that LIS right there in their cloud managing all of that location information. You'll also see in this case, I call out the SBC. Something that's a little bit different from Microsoft Teams. And again, as you, the CCA members, contemplate your types of cloud solutions, you're also going to need to contemplate if you are completely virtual, you know, how is your enterprise customer protected? Do they have their own SBC or not? In the case of Microsoft, the SBC is a third-party SBC that's owned by the enterprise. You might actually use SBCs as part of your service offering to your enterprises. In this case, I'm just representing, in this relatively simple diagram, the way that Teams does it. Their SBC is called out, so we include that as a separate box. The key point here is that the topology of the diagram has not changed. Regardless of the ownership of that SBC in the middle, we move from left to right using I3, SIP invites, to fields of 911, from fields of an optional phone number, p-asserted identities of an optional URI handle, you know, thomasginter@bandwidth.com, and then additional parameters of the geolocation, or in the case of Microsoft, they actually use a different field. It's called a presence information data format location object, or a PIDA flow. I've simplified my dialogue here to to just identify a couple of the parameters in that i3 rather robust protocol just for explanation purposes. Okay, maybe this is the second most complicated slide in the presentation. Your takeaways are the problem statements of telephone extensions with a non-telephone number identifier, of soft extensions with a URI type identifier, of nomadicy to the home environment, okay, where you have a unique address per telephone number or per user ID, the nomadicy in a Wi-Fi environment. All of those are solvable by products like Bandwidth places into the market through the I2 and I3 protocols that are available through our session border controllers and through our provisioning APIs. So this is all off the shelf. And I think that's the end. We can go into question mode. Next slide.
Hey Thomas, before we get into questions, this has been a really interesting discussion, and coming from the point of view of the sort of the compliance lawyer, where the requirement is provide dispatchable location for non-fixed devices or remote workers when technically feasible. I think you kind of answered the question about technical feasibility. It sounds like there are solutions out there that are technically available today. So it kind of puts more emphasis on folks to implement one of these solutions, because it's getting harder to argue that these things are not technically feasible to do. That was my only comment on that.
So I completely resonate with that. So this is true of almost every technology in the last 100 years when a safety measure has been applied to it. Let's go back to windshields, in the 1920s. And the original windshields would shatter and hurt people because it was just a pane of glass like the glass on your in your house window, right? And then they discovered that they could build glass that was laminated with the plastic sheath in between, and everyone's seen how that glass responds to an impact. Because a company solved that safety issue, all companies in short order had to solve that based on the new regulations for safety compliance. What we're illustrating today are techniques to put that sheet of plastic between the glass and provide more safety, and also a Rosetta Stone for how you can build and incorporate those technologies. You're exactly right, Michael.
Great. Guys, thank you so much. We have I don't know, about 10 questions that have coming in. Let me start with the couple from Mark Iannuzzi. Is there any compliance risk of a laptop connecting to an access point on a different floor rather than where you're located? It sounds like a compliance question, Michael.
Well, I think it's a little combination. If you're using a solution that identifies the location based on the access point that the laptop is connected to, I'm not sure you would have that problem. If you're not using that solution and you don't know where that laptop is, or through some other way, then you may have a compliance problem because you're not providing dispatchable location for that non-fixed device.
So I agree with that completely. And from a technology perspective, I always go back to the regulations and go, oh, there's this, what is technologically feasible? Okay. Also, we're walking in the footsteps or in the snowshoe footprints of a rather large company. This is why I mentioned that Microsoft, Skype for Business, and Teams have been doing this since 2012, right? So technically, you're correct. A Wi-Fi access point can spill over to another floor or another room. You can't stop radio, but that location is probably best effort, best technology, based on what's feasible. And when I say the word feasible, it's in italics, and I'm lifting it out of that piece of regulation. We're only as good as the technology allows, right? And there's precedent. So between precedent and best practices, I think we're in a safe haven.
Great. Mark asked another one that I was also going to ask. How is geolocation information gathered at call time? How do they get that? Thomas, I guess, Michael, either one of you guys, go ahead.
So let me take a pass at it, and then Michael jump in. So I actually get this call a lot when I'm talking with our customers. They go, "How do I?" Sometimes they ask, how do you bandwidth find my users? And
Yeah,
I
yeah.
always I always answer, well, if bandwidth can reach into your switch and past your switch into the cloud and then to your users and figure out where everybody is, we can figure out where 335 million people in the United States are. We could sell that product to the NSA for like $1 trillion, but it doesn't exist, right? You, the CCA participant, have to put up either automated location detection. So for example, if you have a little bit of jargon, a SIP user agent on a mobile phone, then dip the GPS, use the lat long, and that becomes your geolocation content. If the person goes from home and are in a occluded IP environment because of a NAT address, and they're on a laptop, you have to pop up a screen. We don't know where you are. Put in your address, and it goes through the regular validation process and becomes that geolocation in the future. There is no magic bullet that covers all of this, and they're only asking for what's technically feasible.
Interesting. So that probably touches on the second half of Mark's question too. How about the geolocation if you don't know the Z coordinate of a multi-level hotel? But Thomas, I think you just touched on that too.
Yes. So it's all about the use case. Is it a Wi-Fi use case? Is it a switch port use case? At the end of the day, I guess one thing I haven't talked about are rainy day scenarios. A lot can go wrong. There's literally 1,000 911 calls that goes through our network every day, and there's going to be some percentage of that are rainy day, bad data, bad location, whatever. If we can get a two-way voice connection to a citizen, we will answer that call manually, ask them where they are, and do a warm transfer. So there's always a safety net of manual handling when the automated piece fails. That's why there's both seatbelts and airbags.
That's great. Again, Michael, this might be directed to you, but Thomas, always jump in. What do the 911 regulations say about work from home users?
Right. Well, again, if you're working from home with a device that's somehow associated, with the enterprise, so you're not, if that connection exists, and I think Thomas explained one solution for that particular problem, the regulations say by January 2022, if that home worker is tied into the multi-line system, you have some flexibility, but you have to have a solution. Again, it's either dispatchable location. Say if it's, in this case, that would probably be just that person's home address. Or you could use a geolocation solution if that works, or you could have some manual input by the person. But that's always a little problematic. I mean, that's been the case for VoIP 911 calls for a long time for nomadic VoIP. Is you have the user ostensibly say, "Oh, no, I've moved to another location. Here's where I am now." But the rules, have a little bit of a smorgasbord of potential ways to solve the problem, but the problem has to be addressed. Again, if there's a connection between the device that's making the call and still back to the multi-line system.
Mm-hmm. Makes sense. Another one, Thomas. What if you have the same phone number, which I do, on a bunch of different devices? You have it on your desk, you have it on your laptop, you have it on your mobile. How do they know where you are? How does that work?
So yeah, there's there's many ways to skin that cat. I can explain a technique, but don't think of it as the only technique. And so let me give you a technique. Suppose you have the same phone number on a hard phone, a laptop, and a mobile phone. Okay. When you make the call through this I3 connection, remember that I said SIP invite to field of 911, from field of the phone number, and this P-asserted identity of another non-phone ID. Well, if you want to, again, here's your $10 word for the day. If you want to disambiguate those three devices, in the P-asserted identity, you go, oh, they all have the same phone number, but I know that device A is my desk phone, and with a fixed address. I know that device B is my laptop, and I need to check what Wi-Fi I'm connected to. And I know that device C is my mobile, so I need to use GPS coordinates. In that P-asserted identity, in this I3 connection, you put your phone number in the from field, but in the P-asserted field, you use the same phone number post-pended with an A or a B or a C to indicate which device is doing the calling. And then contextually in your location, geolocation header, you put in, the reference to the fixed address or the reference to the Wi-Fi address, like that proxy technique that or the latitude, longitude goes directly. And so your SIP invite is always answering the question, who is calling specifically down to the device and where they're calling from using that geolocation field. Again, this is an example. The protocols for i3 or next-gen 911 are rich, and there's multiple ways to do this.
Okay. Shannon asked one, has anyone heard if the cell phone development companies are working on i3? Before either one of you answer that, I see we have Jeff from Poly on the call. He might have an answer to that. We're also, by the way, going to be having a webinar coming up soon on soft phones. So some of that might be answered then, but can anybody answer? Have you heard if any of the soft phone guys are working on i3? Anybody?
So from my perspective, no. I'm currently so the question more completely would be: are the wireless manufacturers, the Samsungs and Galaxies and iPhones of the world, are they having their SIP user agents on the phone, including what would be called a PITA flow? That's one of the other variants of these parameters. I've heard that conversation for years. I have seen no evidence of implementation.
There's also, I think it confuses me sometimes, the difference between sort of a non-fixed nomadic device and a mobile device. The way the FCC sort of thinks about it is a nomadic non-fixed device is a device you can carry around, but it's not necessarily a device that can hop from cell site to cell site or hotspot to hotspot. So it's different than a wireless phone that has its own whole other set of e911 obligations, requirements, and solutions.
I absolutely concur. The definitions are definitions constructed by the FCC. They are as good as that organization can create language that's useful to the people who pass laws. The specifics of the technology you could use the same technology in one device using an FCC label and in another device using a different FCC label, and it's completely blurred. Absolutely. The regulatory guys have a real challenge in creating a crisp definition without being technology specific, and the FCC is explicitly technology agnostic. That's the problem.
Mm-hmm. Michael, what enterprises are exempt from 911 regulations?
None. There's no small business exemption. It's just a matter of if you're smaller, your solutions are easier, right? I mean, if you're a small business and you don't have multiple floors, a big campus, your dispatchable location is probably already solved because it's just your street address. Mm-hmm. Where this gets complicated is when you have larger enterprises and as we've been talking about, you've got employees scattered across multiple floors or multiple buildings or working from home, where it's harder to pinpoint where the caller is. But there are no enterprises. There are no exemptions for anyone on this. As long as it's a multi-line telephone system, these regulations have to be complied with.
Does that apply to call centers too?
Yes, that's my understanding. Yes.
Okay. Let's see. I have a couple more that just popped in. I didn't read this one yet. I'm going to read it out loud with everybody. I thought there were very few 911 call centers that support next-gen 911. How can you provide next-gen 911 service if the public safety side is not ready to support the technology?
Sure. So that's totally true. So this is why I really went to those definitions of I1, I2, I3, enhanced versus basic. All of that language. You kind of have to sort that all out in your mind, and bear in mind that bandwidth is in the middle between a legacy PBX and a legacy 911 call center. We're in the middle between an advanced cloud services CCA participant using I3. We're between them and the legacy public safety answering point or the next gen public safety answering point. And so we're doing a bilateral translation of whatever name, number, address information comes in to how it needs to be displayed to public safety. And just so that you understand the complexity, 5,545 independently managed public safety answering points with about 50 different dialects of protocol, right, to deliver that information correctly to their screen. This complexity, you don't have to worry about. If you use an I2 or an I3 connection to us, we handle everything downstream. This is not just we bandwidth. You know, I'm talking about the emergency services providers that are similar to bandwidth as well. Anything I'm talking about in that regard is generalized.
Great. Thomas, Michael, thank you. Everybody, thank you for joining us today. Another really fascinating webinar. Mark, thank you for putting this together. We hope to see you on the next one. Our next webinar is in July. We're going to be doing a Microsoft Teams V.2 webinar. The first one was sold out capacity, so we're going to do it again with some different perspectives. So hope to see you on the Microsoft Teams. Feel free to call us if you need anything. Thanks a lot, and everybody have a great rest of the day. Gentlemen, Thomas, Michael, again, thank you one more time. Excellent.
Thank you.
Our pleasure.
Have a good day, everybody.